This is lesson 13.6, factoring trinomials. Well, first of all, practicing factoring, so things that we've already learned. So factor completely, and then if it's not factorable, just write prime. So number 1, m squared plus 12m plus 36. So we've learned how you look for numbers that you can add to be 12 and multiply to be 36. And so 6 and 6 come to mind. So I could say m plus 6 and then times m plus 6. And so that's factoring the trinomial. Number 2, there is a GCF, and so k goes into both, so I'm going to take k out. So k times k is k squared, and then times negative 2 would be minus 2k. Remember that you can always check your factoring by multiplying it back and making sure that it works. Number 3, there's no GCF. Because it's a binomial and not a trinomial, I can't use X games for that because it just doesn't work when you have a binomial. So the other thing that you need to look for is see if it's a difference of squares. This is a perfect square. The square root of that is 4m, and this is a perfect square, and the square root of that is 5. And because this is a minus, this is a difference of squares. So because it's a difference of squares, I can factor that as 4m plus 5 and 4m minus 5. Remember, if that was a plus in the middle, you cannot do this. It would be non-factorable. Okay, and then number 4, just looking real quickly, if I was just looking at those two numbers, there would be a GCF. But because 9 is thrown in, there is no GCF. So I look at this, because the leading coefficient is not a 1, the X games don't work. So this is one where I have to just kind of puzzle it out. And I know that I have to get my first two terms have to multiply to be 4k squared. So I'm going to think of 2k and 2k. My last two terms are going to have to multiply to be 9. So I can either do 1 and 9 or 3 and 3. And so 3 and 3 sounds good. So let me just see if that works. So if I do 2 times 2, I'm going to have 4k squared. And then I would have 6, either positive or negative, depending on how I do the sign. I'll have another 6, again, positive or negative, depending on how I do the sign. And then I'll have a 9. This is going to work, I think. So if I go back and say I have to have that be a positive 9, either they're both going to have to be positive or they're both going to have to be negative 3s. Since I want my middle term to be a negative 12, if I do a minus 3, I'm going to have 4k squared minus 6k plus 9. That's going to work. So my final answer of how to factor this is 2k minus 3 times 2k minus 3. You could also write 2k minus 3 quantity squared. Okay, so what we're going to do now is we're going to look at equations and we're going to factor them. And so there's something called the zero product property. And basically what that says is it says that if you take two numbers and they multiply to give you 0, either A has to be 0 or B has to be 0. That's the only way that that can happen. So we use that zero product property to be able to solve using factoring. So we're going to start out with an equation that basically has already been factored for us. And so looking at number 5, I am being told that 8 times r minus 8 times r plus 5 is 0. So using the zero product property, that means that either 8 is 0, or r minus 8 is 0, or r plus 5 is 0. Well, obviously 8 is not equal to 0. r minus 8 could be 0 if r was equal to 8, and I just get that by adding 8 to both sides. And r plus 5 could be equal to 0 if r is equal to negative 5. So if these two is what r is, that would actually solve the equation. So I have two solutions, and that's going to be 8 and negative 5. So just showing you what that means, it means that if I plug 8 in for r, it's going to be a true statement. Because then I'm going to have 8 times 0 times 13. Well, since anything times 0 is 0, that works. It also means that if I plug in negative 5 for r, it's going to be a true statement. So I'd have 8, negative 5 minus 8 is negative 13, and negative 5 plus 5 is 0. So here again, because I've got something times 0, it's going to be equal to 0. So that's going to work. These are the only two numbers that I can plug in for r that would work for this equation. So I've solved the equation, and I used a factored expression to be able to do that. So number 6, we do this the same way. Either 4 has to equal 0, or r plus 4 has to equal 0, or r plus 8 has to equal 0. Obviously, 4 is not equal to 0. If r plus 4 is equal to 0, then that means, if I solve it, that r is equal to negative 4. If r plus 8 is 0, if I solve that, that means that r is equal to negative 8. So the two solutions for number 6 are negative 4 and negative 8. Now you might wonder if there's always two solutions. If we have what's called a quadratic equation, then yes, there are two solutions. And it's quadratic if the highest degree is a 2. So if we were to multiply all of this together, and so if we took 8r minus 64 and then we multiplied it by r plus 5, I'm going to get an 8r squared, and that's the highest degree. So this would be a quadratic. And so if you have a quadratic, there are two solutions, and so we are going to be getting two solutions on these that we're doing in here. So number 7, 4 is not equal to 0, and so I actually don't have to write that down, because if you see that that's 4, then you don't have to write that down because obviously it's not 0. But if it said 4x, then you would have to write it down. So I'm not going to worry about that one. But I'm going to say x minus 8 equals 0 or x minus 1 equals 0. That means that either x is equal to 8 or x is equal to 1. So my solutions are 8 and 1. Whoops. And number 8, if 2b minus 3 equals 0, it's going to be a true statement, or if b plus 7 is equal to 0. Because if either one of those is 0, then times the other one, it's going to be 0. Okay, so looking at 2b minus 3, I'm going to add 3 to both sides. So I'd have 2b equals 3 and divide by 2, so b is equal to 3 halves. That's one of my solutions. If b plus 7 equals 0, then that means that b is equal to negative 7. So my solutions here are positive 3 halves and negative 7. So that's an example of how you would solve an equation using expressions that are already factored. And so next we're going to go to equations that have not been factored. So number 9 says find the roots and zeros and solutions. Those are all synonymous. They mean the same thing. We're finding the numbers that will give us a true statement. And so we're going to find the roots by factoring and then write your answer in set notation. So the first thing we need to do is we need to make sure that it says 0. Because there's not a 1 product property or a 5 product property. There's only a 0 product property. So we have to make sure that on one side of the equation it's equal to 0. So if that said equals 5, I would need to subtract 5 from both sides. Okay, so what I'm going to do next is I'm going to take this part of the equation and I'm going to factor it. So we're going to look at v squared minus 8v plus 12. So all the ways you've learned how to factor it. There's no GCF. I can use X games on this, so if you still need to draw that out, then that's fine. So you're looking for numbers that add to be negative 8 and multiply to be 12, positive 12. And so if I look at what I can do with that, I can do negative 2 times negative 6. Those would add together to be negative 8 and multiply to give me positive 12. So I'm going to have v minus 2 times v minus 6. So that's factored, and then it's still equal to 0. So now I'm set up like I was on the previous problem. So either v minus 2 has to equal 0 or v minus 6 has to equal 0. In this situation, v is equal to 2, and in this situation, v is equal to 6. So my two solutions are 2 and 6. Okay, pause the video and try number 10. You're going to be factoring on the left and then solving it. When you solve number 10, the first thing you're going to do when you factor is you need to notice that there is a GCF. Like I've told you that before, that is the first thing you need to look for. There's a GCF, and so I need to take that out. So once I've taken that out, I have 5 and then times the quantity of b squared plus 3b minus 28. This in here can still be factored. So I'm going to carry that 5 along, and I'm going to be factoring what's inside. So I know that I'm going to have b's right there, and then I'm thinking of a number that would add to be positive 3 and multiply to be negative 28. And so negative 4 and positive 7 would do that. And so now if you look, this is very similar to a question like, say, number 5. And 5 is not going to be 0, so I don't need to worry about that. But b minus 4, if that was equal to 0, then that would give me a 0 as my final product. which would mean that b is equal to 4. If b plus 7 was equal to 0, then that would mean that b is equal to negative 7. So my solutions, and I'm going to have to erase some of this work, but my solutions are going to be 4 and negative 7. Okay, number 11 through 14, we're solving by factoring. The difference with this set of problems is that there's not a 0 on the one side of the equation. So what you'll need to do is get everything on one side so that there's a 0 on one side of the equation, and then look for a GCF, factor it completely, and then you'll be able to solve it. So I'm going to do the first one with you. I'm going to start by adding 48 to both sides. So I'm going to have 2b minus 22b plus 48 equals 0. So now that's set up the way I need it to be set up. The next thing I need to notice is that there is a GCF. So if I take out a 2, that's going to give me 2 times b minus 11b plus 24. Okay, that's what I need to factor now. So I'm going to carry the 2 along. I'm looking for something that adds to be negative 11 and multiplies to be positive 24. So when I think of the factors of 24, 3 and 8 would give me an 11, and if they were both negative, then they would add to be negative 11 and multiply to be positive 24. So what that means is it means that 2 is not equal to 0, so I don't have to worry about that. b minus 3 equals 0, which would mean b is equal to 3, or b minus 8 is equal to 0, which would mean b is equal to 8. And so that's how you do that problem. So my solutions are 3 and 8. Okay, so now I want you to pause the video, and you're going to work through 12, 13, and 14. Remember, everything goes on one side. You need to look for a GCF because that is going to be something that you're going to see in some of these problems, and then you're going to factor it and find the solution. Remember, you can always check. So you need to pause and so that you can do these 3 problems. Okay, doing number 12, you should have 6k squared minus 60k plus 126 equals 0. If there's ever a leading coefficient of other than 1, you need to look for a GCF because chances are very high, at least in this level of math, that there will be a GCF. So 6 times k squared minus 10k, and then 6 goes into 126 21 times. So when I look at this, this is the part that I'm going to need to factor. The 6 is going to come along for the ride. So I'm going to have k squared. Whoops, I didn't mean to write that. I'm going to have 2 parentheses, and I know that it's going to be k times k. I'm looking for something that multiplies to give me 21 and adds to give me 10, so I'm thinking of 7 and 3. If they were both negative, that would give me a product of positive 21 and a sum of negative 3, so that's what I'm going to use. So 6 equals 0, not a thing. K minus 7 is equal to 0, that means that k is equal to 7. K minus 3 is equal to 0, which would mean k is equal to 3. So my solution for this problem, I'm sorry I don't have more room to keep all of this up here, but my solution is going to be 7 and 3. It doesn't matter the order that you write these in when you're doing it in set notation. I mean, it's nice if you do them in numerical order, like 3 first and then 7, but I don't really worry about that too much. Okay, number 13, everything on one side, so I'm going to add 7x squared, so I'll have 6x squared minus 24x, and then I'm going to add 18 to both sides. Okay, so here again, because that leading coefficient is not 1, I'm seriously looking for a GCF, because if there's not a GCF, it really makes the problem a lot harder. Not that there's anything you can do about it if that happens, but try to make it easy on yourself. Okay, so when I go to factor this, I'm looking for something that multiplies to give me 3. Well, the only options I've got are 1 and 3, but fortunately that will give me a sum of negative 4 if they're both negative. So 6 is not 0, so that one is not something I'm going to be writing down. But x minus 1 equals 0, that means x equals 1. X minus 3 equals 0, and that means x equals 3. So my solution for number 13, I'll write it up here, is 1 and 3. Okay, last of all, number 14, I need to get the 2r on the other side, so I'm going to have r squared. This is minus 2r, and when I subtract 2r, I'm going to have minus 4r. and then I'm going to have plus 3 equals 0. So I see myself kind of in the same situation that I was right over there, except I don't have a leading coefficient to pull out. So this is actually the same factorization that I just saw. And so r is equal to 3, or r is equal to 1. So you see, this one has the same solutions to the equation as the previous problem did, even though the equations aren't the same. And that can happen. It's just like if you have a linear equation and you get a solution of 3, that doesn't mean that's the only equation that can have a solution of 3. So that's how you're going to do those problems. Okay, the very last thing that we're going to do is I'm going to give you the answers, the solutions to an equation. I want you to tell me what the equation is. So the directions say write a polynomial function of least degree. And the reason I say least degree is because it is possible to get a higher degree equation with these solutions, but we're trying to make it so that we all come up with the same thing. Integral coefficients means you can't have any fraction coefficients. So you can't say like x plus 3 halves. And that's not going to be something we're going to have that has the given zeros. So the given zeros, that means that these are my solutions. So the way we do a problem like this is we're working backwards. We're working from the solution to the problem. And so I'm going to literally do everything backwards. So I'm going to start by saying x is equal to 5. X is equal to 1. Those are my two solutions. So if I work backwards, if I subtract 5 from both sides, I'm going to have x minus 5 equals 0. X minus 1 equals 0. Well, if you think back to the other problems we've done, when we had that point, we came from a factorization. So I would say x minus 5 times x minus 1 equals 0. That's my polynomial in factored form. And so to get the polynomial function with integral coefficients, I'm going to multiply this together. And so I end up with x squared minus 6x plus 5 equals 0. That is the polynomial with the least degree that will have the solutions of 5 and 1. Okay, so I want you to try number 16 and 17. You're trying to come up with the equation that will have those coefficients. So pause the video and come back when you're ready. Number 16, x equals negative 3 or x equals 5. So that means that x plus 3 equals 0 and x minus 5 equals 0. So if I take both of those as a factor, that's the factored form of my polynomial. Now multiply them together using distribution. So x squared minus 5x plus 3x minus 15 equals 0. So x squared minus 2x minus 15 equals 0. And then number 17, we're going to start with x equals negative 4, x equals negative 5, which means x plus 4 equals 0, x plus 5 equals 0. So I'm going to have x plus 4 times x plus 5. Multiply it together. I end up with x squared plus 5x plus 4x plus 20 equals 0, which gives me x squared plus 9x plus 20 equals 0. Remember that since I'm asking you for a polynomial function, or in other words, a polynomial equation, you have to have it equal to 0. You cannot just give the left-hand side. You can't just give the expression. An expression does not have a solution. An expression does not have roots. It does not have zeros. So you have to give an equation in order for that to happen. Okay, you should now be ready to do your homework for this section.